All right, so in this video, we're going to be going over Journal 20. To get that journal, just hit modules and you'll go and find it in our news section. Once I publish it, you should be able to find Unit 3, Journal 20. You'll click on that and that's how you'll find the journal. By the way, in this journal, we're going to definitely need a scientific calculator or graphing calculator. So if you are needing a graphing calculator, feel free to use any of these products that I've listed down below. GeoGebra is great. So if you click on it, you'll find some helpful function keys. So we're going to need to be using exponents a lot and fractions. So exponents, you can use this here to get an exponent. You can press on this to get fractions. And then if you need E, if you guys remember in Algebra 2, you guys learned about E, which is also kind of like pi. It represents a number 2.718. If you guys remember that, probably no one does. No worries, we'll learn about it again in this chapter. So I thought I'd show you guys some of the functionalities with GeoGebra if you prefer to use the online tools. If you want something more similar to a TI-84, because you're used to that system in the classroom, check out Calc 84 and Calculate 84. These are apps for the iPhone and the Android devices. You can download for free, and they are emulators of the TI-84 system. All right, let's get started. So I'm going to transfer over to my iPad here. Give me one moment while I sync my iPad. All right, so this is 980, 385, 118, 7246. Wrong one, this one. All right, so in this journal here, we're going to be talking about exponential functions and their graphs. So before we get into the graphing part, let's just talk about how do we take care of exponents, because this chapter is all about exponents and finding exponents and dealing with the base for exponents. So as you can see here, I've made all of these bases 3, and I'm going to check what happens when I throw in a positive exponent, a negative exponent, an exponent when it's 0. What does that do to the value? And then we'll also talk a little bit about E. So on here, 3 to the second power, you guys probably know 3 to the second power is like saying 3 times 3, and this would give us 9. 3 times 3 is 9, and so we have that value. Or you can use the calculator. If you go to, I'll use Calc 84, so this is the simulator. So if you do 3, if you type in 3, and then you hit this button here, which looks kind of like an arrow, but it's what we call the exponent button or a caret button. And then you type in 2 and hit enter. That's how you get to exponent and you get 9. All right, so back to that other problem here. So this is 3 to the negative 2 power. So you might remember if in Algebra 2, anytime you have a negative exponent, let's use x to the negative 1 power. Anytime you have a negative exponent, what happens is you need to make it positive. And so to make it positive, you put it in the denominator, and now it becomes a positive 1 exponent. So the reason why negative exponents causes things to go to the denominator or for it to flip is because negative exponents mean take the reciprocal. So if you think about x for a moment, if you put it over 1, anything can be put over 1. If this is a negative exponent, that means it's going to flip. So now it's 1 over x. Another case is like, just to kind of show you guys, if you have 1 over x to the negative 1, then because there's a negative exponent, we don't like negative exponents, so we'll change it back to a positive. And so now x is in the top and 1 is in the bottom, so x over 1, or you can just call this x since 1 in the bottom is redundant. So negative exponents causes it to take the reciprocal. So if I see 3 to the negative 2, the first thing I'm going to take care of is that negative exponent. So I'm going to put it in the denominator as 1, 3 to the second power. So Now this 3 to the second power is in the denominator, and so now it can be a positive exponent. But 3 squared in general is 9. So this is 1 over 9, or if you put this in the calculator, 1 divided by 9 is 0.11, I believe, if you carry it to like 2 decimal places. So actually, let's do 3 just in case. So it'd be 111. Let's double check with the calculator. So if I just do 3 to the, so I'm pressing this button here, 3 to the negative, let me clear that. I think I did that wrong. 3 to the negative 2 power, and hit enter, you get 0.111. Or if I just do 1 divided by 9, if I didn't use the exponent button and I did it by hand, I still get the same number. So that's a number that I'm rounding off. Oops. There we go. Sorry, I keep hitting the wrong button. So it looks like 3 to the negative 2 power is about 1/9. And essentially what I want us to graph from that is anytime you have a negative exponent, it causes it to go into the denominator or flip. Anytime you have an exponent that's 0, if you guys remember, any exponent that is to the 0 power causes it to be 1. So x to the 0 power is 1. 1,000 to the 0 power is 1. Anything to the 0 power is 1. So that is my final answer. And if you don't believe me, just feel free to use the calculator here. So 3 to the 0 power, typing that in, is 1. 1,000 to the 0 power is 1. Anything to the 0 power is always 1. All right, now this one here is e to the first power. So I raised it to the first power just so that we can see what is e in general. So e is just like pi. So pi is this constant that represents 3.14, and it goes on and on forever. It's decimals. We don't always write all the decimals. Instead, we use a symbol to represent it, which is this pi symbol. For e, it represents this number, and we're going to figure that out using the calculator. So I'm going to type in e. And by the way, your calculator can do e. So let me clear this. Just hit second. So you're going to press second, and then you're going to press ln, which is to the right, or not the right, the left, far left, ln, and then you'll get e. And so then you're going to type in 1 for the exponent and hit enter. And it is 2.718. And then I'll just round it to 3 decimal places to make this less complicated. But you can use the calculator to figure out the value for e. So it's 2.718. And then it goes on and on forever, just like pi. So this number here is a very special number. E is what we call the natural base. Let me write that here. So E is what we refer to as the natural base. And the reason why we call it the natural base is this number here is quite a phenomenon in the real world, just like how pi, the 3.14, crops up all the time when you're dealing circles. Well, E crops up all the time when you're dealing with exponential graphs. So a lot of times you'll see E pop up when you're talking about population growth, or when you're talking about chemistry and like something called radioactive decay or half-life. You'll notice that E will crop up, or bacteria growth. E will show up a lot in natural situations. And so this is a kind of a phenomenon. And so this number is going to be symbolized using the letter E, and that happens because it was discovered by a mathematician named Euler, and so his name started with the E. So that's basically a short story of where E comes from and why it's significant. But what we're going to be dealing with in this chapter is a lot of exponents. So what we're going to do is have the x's be the exponent, so that way we can make them vary. So we're going to vary the exponents, but we're going to choose the base to be some value. So you'll notice that x is no longer the base. Instead, the base is a number, a value, and x is going to be the exponent instead. And we'll see what happens to the graph. So in this lesson here, we're going to learn what does the graph look like. And to figure that out, we always like to make a t-chart so that way we can plot some points. So let's pick quite a few points for our t-chart. Usually we only pick like 3, but let's pick like 5 so that way we can get an accurate picture since we're just starting out. So I want to know, what does 2 to the x power look like on a graph? And so I'm going to pick some negative values, maybe like -2, -1, 0, and 1 and 2. So some negative, a 0 is always a good one to throw in, and then some positive numbers. And so these are x values that I'm going to plug in for x and then just figure out what our y is. So that way I can get my coordinates. So 2 to the -2 power. So 2 to the -2 power. Now, we just mentioned before, anything to the negative power flips. And so this is now 2 to the second power. So that way it can be positive. But 2 to the second power is 4. So this is really 1/4. And then if I do 2 to the -1 power, this would be 1 over 2 to the first power on the bottom, because negative exponents cause the base to be in the denominator instead. So 1 over 2 is just 1/2. 0, plug it in for x, that's going to be 2 to the 0 power. Anything to the 0 power is just 1. And then if I plug in 1 into this equation, this is 2 to the first power, which is 2. 2, plug it in for this 2. X is going to be 2 to the second power, which is 4. All right, so I have my y values and I have my x values. So at -2, which is here for x, it goes up about 1/4. So that's like 0.25. So it's like right there, like a tiny bit up, but only about 0.25 up, a fourth up. And then at -1, it's about a half up. So like right there. And then at 0, it hits 1. At 1, it hits 2. And then at 2, it hits 4. So we can kind of see this growth, that it grows upwards here. So I'm just going to follow the curves. But one of the interesting parts is where it goes when it goes to -infinity. So this side is going to -infinity. This side's going to positive infinity. We can definitely see as x is approaching positive infinity, this is growing exponentially. So that means it's growing really fast. So it's going upwards. Whereas this side is starting to kind of like shrivel down, slowing down quite a bit. And if we think about it, it's because when you have a negative exponent, right, it keeps making the denominator bigger because the number is getting thrown to the denominator. And so if you're taking a number and you're dividing it by a large denominator, turns out that number starts to approach 0. And so this side here is actually starting to approach the x-axis, where y is equal to 0. So if this is approaching the y-axis, then that means that we have an asymptote, because as it moves down this side, it's going to slowly, gradually get to y equals 0, but not um, quite touch the asymptote here. So it's going to get really, really close, but not quite touch it, and that's what we call a horizontal asymptote. So horizontal asymptote, or HA, is a horizontal line, an imaginary horizontal line, where the line gets really, really close but doesn't quite touch it. So usually I like to use like a dashed line to represent this, or a highlighter to represent the horizontal line. And so this side is going to start growing upwards. This side's going to get really, really close to y equals 0, but not quite touch it. Let's see what happens when the exponent is a negative x. So again, we're going to make a chart here. And this is going to be x and y. And I'm going to just use the same values. So -2, -1, 0, 1, and 2. And then I'm just going to go ahead and plug these numbers in for x. Now, because this is a -2 that's getting plugged in, 2 negatives make that a positive. So this ends up being 2 to the second power. So if I plugged in a -2 in for here, that would become a +2. And so this would be a 4. Same thing if I plug in a -1, this would become a +1. So I get 2. 2 to the 0 power is just going to be 1. And And then if I plug in 1 into here, that's going to be 2 to the negative 1, which ends up being, again, that 1 over 2 to the first. So 1/2 again. And then 2 to the negative 2 power. So if I plug in 2 in for here, this would be 2 to the negative 2. So I've written it down here. And so that would be 2 to the second power, but it's going to be in the denominator because that's a negative exponent. So that'd be 1/4. All right, so we're ready to plot. So at negative 2 here, it goes up to 4. So that's going to be up here. And then at negative 1, it's at 2. At 0, it's back up to 1 again. And then at 1, it goes to 1/2. So it's like halving now. And then at 2, it takes about just half of that. So that's 1/4, about right there. So I got 1/4 when it was at 2, when x equals 2, it's 1/4. And we can see, again, it does the same thing, but now it's like flipped. And so as x is approaching positive infinity, it's now getting closer to the asymptote. Again, this is another asymptote at y equals 0. We'll call that the asymptote. So it looks like this side is getting closer to y equals 0. So we have another asymptote, whereas this side is going to grow upwards. All right, so from here, let's see. We have our two graphs. So let's go ahead and compare that with each other. So it looks like this one here is growing upwards. And so we can kind of see with this one, this is what we call a oh, sorry, I just realized I thought I made a mistake, but never mind. So going back to this here, this one is what we refer to as an exponential growth. This is an exponential growth because this is growing upwards as you're moving towards the right or as you're approaching x to positive infinity. And it's also increasing. Now, this is not always the case that an exponential growth is increasing, but this one definitely is increasing because as you move further to the right, it is jumping upwards. So this is growing very high as you're approaching to the right. Whereas this one here, you can see it's kind of falling downwards. So it's definitely decreasing the more you go to the right. But notice that it's starting to slow down as you're going to the right. So this is what we call an exponential decay, and it's decreasing. So to kind of talk a little bit more about this, to summarize things here, when it comes to graphing exponential functions, you're going to be dealing with horizontal asymptotes. And usually you can tell what the horizontal asymptote is if you look at what is on the side. So if you have your base, usually you have a number to this. Sometimes you'll have a number to the side, and that will cause the horizontal asymptote to shift. So let's go over a few things about graphing exponential functions. When you're graphing an exponential functions, you need to be aware of the base. Actually, let me write that over here so I have some room. So we have the base, which is your b, and then you have your what we call the h. Let me point on that. So the h is your horizontal shift. And a negative means that you're going to be going right, and a positive means that you're going left. So this might seem very familiar. So the shift is going to be in the exponent spot, but that's going to be your horizontal shift depending on if it's being subtracted from x or added to x. And then your k, you can probably guess it, is your vertical shift. But it also tells you your horizontal, might have to abbreviate, but your horizontal asymptote. It's a T, by the way. So your vertical shift also displays your horizontal asymptote. So notice that this one here didn't have a horizontal, didn't have any shift here. So we can assume that this is +0. So that's why the horizontal asymptote is at y=0. But if we added, let's say, a +1 here, +1, then this would be shifted up 1, and that would be the horizontal asymptote. So just to kind of give you some background on that, the shifting here. So B is your base, H is your horizontal shift, and vertical shift is pretty much the same as before. Positive means up, negative means down, but it also represents the horizontal asymptote. And that's pretty much it as far as the basics when it comes to shifting. Another thing I want to mention is about how to figure out if something is an exponential growth or an exponential decay. And the way you figure it out is your base. So if your base is greater than 1, if it's a number that's bigger than 1, that means you're more likely to get an exponential growth. But this is only if your x is positive. So like with this one here, to give you an example, notice that your base here is 2. Your base here is 2. And your x here is positive. So b here is clearly is bigger than 1. And then your x is positive, so you had an exponential growth. But if you have the case, if b is not bigger than 1, maybe it's a number between 0 and 1, so it's a fraction. Any numbers between 0 and 1 tends to be a fraction or a decimal. Um, then this might cause your graph to be an exponential decay. If your x is negative, so if your exponent x is negative, then this would also cause it to have an exponential decay. So I want you to notice with this one here, your base is 2, so it's still bigger. Your base is still bigger than 1, but notice how your x here is negative. And so with that negative x being there, it's causing it to decay over time or decrease um, in its growth over time. All right, that is it for this video. In the next video, we're going to practice graphing exponential functions. I hope you guys found this helpful. I'll see you guys in the next video.